Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube. Good morning. Today I am discussing about the workshop practice. That is the sessional paper dedicated only for first year of mechanical engineering and computer science engineering. Workshop practice. Actually, what is the definition of workshop? Why the workshop is required? Actually, workshop practice is a very vast one and it is very difficult for anyone to claim mastery over it. It provides the basic working knowledge of the production and properties of different materials used in the industry. It also explains the use of different tools and equipments, machinery and techniques of manufacturing, which ultimately facilitate shaping of this material into various usable form. Now, in general, various mechanical workshops know by long training how to use workshop tools, machine tool, equipment. Trained and competent person should be admitted to this type of a mechanical work, permitted to operate equipment. Ores, that is the raw material for industry. Another one is the to suitable reducing refining process, convert the metal into molten form. This molten metal poured into mold to give commercial casting called ingots. From suitable process to obtain usable metal products of different shapes and sizes. Okay. Primary shaping processes, machining processes, joining processes and surface finishing processes. Processes affecting change in properties. One is the primary shaping process. Okay. Primary shaping processes, actually some of these finish the product of its usable form, whereas other do not it require further working to finish the component to the desired shape and size. Wire drawing lead to the directly usable article which do not need further processing before use. Workshop practice casting, forging, bending, rolling, drawing, power metal forging, etc. Machining processes. Large number of components need further processing after primary processes is known as secondary operation to obtain desired shape and dimensional accuracy. These operations require the use of one or more machine tools of various types of cutting tool and cutter, job holding devices, marking and measuring instrument, testing devices and gauges, etc. Common machining operations are turning, threading, drilling, boring, planing, shaping, sewing, milling, grinding and slotting. In the lathe, turning, threading, okay, joining process. These processes are used for joining metal parts. And in general fabrication work, such requirements usually occur when larger length of standard sections are required or several pieces are to be joined together to fabricate desired structure. Common processes are welding, soldering, brazing, riveting, screwing, and pressing, etc. Surface finishing processes. This process should not be misunderstood as metal removing processes in any case, as they are primarily intended to provide a good surface finish or a decorative and protective coating onto the metal surface. Although a very negligible amount of metal removal or addition may take place. Thus, any appreciable variation in dimensions will not be affected by these processes. The common processes employed for obtaining desired surface finish: buffing, polishing, lapping, belt grinding, metal spraying, and painting. Processes affecting the change in properties. These processes are employed to impart certain specific properties to the metal part so as to make them suitable for the particular operations. Most physical properties like hardening, softening, and grain refinement, etc., call for particular heat treatment. Heat treatment not only affect the physical properties but in most cases also make a marked change in the internal structure of the metal. So, is the case with cold and hot working of metal. Heat treatment, cold working, another one is the hot working. And when you go to the workshop, the safety in workshop has been written not only to provide appropriate safety procedure but also to assist trained workshop personnel with the provision of a reference document outlining the general principle of safe working practices relevant to the mechanical engineering aspects. It relates to specific or as where definite safety measures are required for workshop operation. Factories Act and Accident. Various acts relating to accident are spelled out in Workmen Compensation Act 1923. The Factories Act 1948, Fatal Accident Act 1855. This act describes the regulation for fencing and guarding the dangerous machinery items and employers' liabilities. Concept of accident. It is very difficult to give a definition of the word accident. Generally accepted conception that an accident is a mishap, a disaster that result in some sort of injury to men, machines or tools and equipments, and in general loss to the organization. The said injury or loss may be of minor or major nature, and the accident is termed as non-reportable or reportable. For example, small cut on the body will be reportable accident in a training workshop. It can be treated by first aid and does not involve any appreciable loss of time. and will not be considered a reportable accident in a production unit. Causes of accident. The 98% accident could be easily avoided provided due precautions are taken well in time. A very familiar slogan goes on to say that accidents do not just happen but are caused due to failure of one element or the other. And the most unfortunate factor is that the human element is the most pronounced of all which fail. The common causes which lead to accidents are the following: unsafe working position, improper or defective tools or their improper use, improper act which result the violation of safety rules and non-observation of safety precautions. Common sources of accident: the large number of machines in use and an even larger number of parts. These can be regarded as sources of danger and require guarding for protection against accident. Some common sources of accidents are listed below. Projection nips between sets, revolving parts, gear, rolls, and friction wheels. Projecting fastener on revolving parts, revolving cutting tools, circular saw blades, revolving drum, crusher, spike, cylinder, and armed mixer, revolving shaft, spindle, bars, and tools like drill, reamers, boring bar, and chucks. Projecting sharp edges on nip of belt and chain drives, that is belt, pulley, chain, sprocket, and belt fastener. Reciprocating tools and die of power presses, drop hammer and revolving presses, etc. Grinding wheels and stone, reciprocating knives and saw blades such as cutting and trimming machine and power hacksaw, etc. Revolving drum and cylinder without casing such as concrete and other mixer, intermediate feed mechanism, projecting nips between various links and mechanism like cranks, connecting rod, piston rod, rotating wheel and disc, etc. Common method of protection. The common method of protection against accidents are the following: safety by position, safety by construction, safety by using interlock guards, safety by using fixed guard, safety by using automatic guards, safety by using distance guard. Safety by construction. When a new machine is designed, it should be ensured that all its dangerous parts are either enclosed in suitable housing or provided with suitable safety guards. For example, the belt drive and the motor in a lathe or milling machine are enclosed. The back gear in a lathe are either enclosed or provided with cast iron guards or covers. Lubricating points are provided on the outer surface so that interior parts are not required to be opened every time. Safety by position. The machine design is in such a way that the dangerous parts are located such that they are always beyond the reach of the operator. The dangerous parts of all machines should invariably be guarded, and undertaking should be made to make them enclosed in the body or housing of the machines. Safety by using interlock guards. It is very efficient and sound method of guarding in that The guard cannot be removed and dangerous parts exposed until and unless the machine is totally stopped. Similarly, the machine cannot be started to work unless the guard returns in position and protects the dangerous parts. An interlocking guard may be mechanical, electrical, or some sorts of a combination of these. It is essential that it should prevent the starting and operation of the machine in case of interlocking devices fails. Always acquire its position to guard the dangerous parts before the machine can be started. Remain closed in position until the dangerous part is completely at rest. Safety by using fixed guards. These guards either for main integral part of the machine or are tightly secured to them. They should be made to have rigid construction and should be so placed and that any access to the dangerous parts of the machine is totally prevented in the running condition of the machine. Steel sheet can be advantageously used and they facilitate an easy fabrication of guards and are lighter in weight. In some cases, the fixed guards are made adjustable in order to accommodate different kinds of works or set of tools. In some cases, the fixed guards are provided at a distance from the danger point. Safety by using distance guard. The principle of a distance guard is that a fencing enough high is made of bars at a suitable distance from the machine such that even if the operative by chance extend his hands over it, his finger, clothes, or any part of the body does not reach within the area of a dangerous parts. An additional measure of safety, some sort of tripping device is also usually incorporated to stop the machine quickly in case of an accident. Safety by using automatic guards. The principle of an automatic guard is that its operation is actuated by some moving part of the machine. It may be linked that the part will automatically bring the guard in protecting position before the operation of the machine starts. The design of the guard is such that it automatically forces the operative away from the dangerous area of work before the operation starts and does not permit hits because to the area again until and unless the machine stops. It may be noted that due to enough time being required for their operation, this type of guards are not suitable for quick acting and fast running machines. Their use is largely favored for heavy and slow acting machines like heavy power presses. So workshop, when you enter the workshop, there are some rules and regulation. You have to wear tight clothes, you have to wear the shoes, okay. Loose clothes are strictly prohibited, okay. And when you do any type of work, okay, you should be careful. Okay, and you have to make a copy for this workshop, wrote down all these things, and finally it will be signed by the teacher. Okay. Last, if you like my video, you have to subscribe. Okay, thank you.